Hello everyone, this is Bradley. Today we're going to talk about this kind of knitting show animation type A. We're going to use the UV sampling method we've discussed in the past. So let's start. So here we are in Blender, and here's a show model I downloaded from the internet. You can download that as well from the link in the description. It's free. However, I modeled these main parts by myself. I remodeled that. And the way I model that is basically just to take a plane and maybe I add some loop cut so that I can model the bottom of the shoe, like decrease this edge and doing whatever stuff. And after that, I just extrude it and delete one face. So finally it ends up something like whatever. Okay. This is not a modeling tutorial and I do not want to discuss that further. The reason I remodel this main part is because I need a clean topology for UV unwrapping. Okay, and this show model obviously has a kind of subdivision surface to smooth out. Okay, and the way of UV unwrapping is basically you just hold Alt and select an edge, okay, and you can mark the seam. Once you can hit U and mark the seam, okay, and once you mark the seam, it will be shown as red line. And what's important is again you hit U and there will be an unwrap option. Okay, you unwrap that and you can find this UV in UV editing panel. Okay, this UV is not ideal, but we will come back later. Let's firstly start with a geometry node tree, and we're going to add the geometry as the original show model, but we're going to use this grouping but later. So for now, we're going to use a curve linear. You can download all these presets for free from the link in the description, but essentially it's just a curve line node plus resampling and so on. Okay, and I'm just going to point the instance the curve line, and this is a line on the x-axis. I'm going to instance that on y-axis. So I have this kind of whatever. Okay, here I just want to mention that the UV surface is 0, 0 to 1, 1. This is the UV coordinate. And right now we're instancing everything in the range of -1 to 1, 1. They are different, but it's completely okay. I only want to mention that we're working at a square area for correct mapping, so that we do not need to stretch anything later. Okay. In order to deform all these kind of points, let's take a realized instance. And just to note two parameters, one is the count 1 and the other is count 2. So if you increase the count, you increase the instance. And if you increase the second count, you're increasing the subdivision of every individual curve. Okay. And then we're going to use the preset called UV Deformer. I've discussed this preset and I even discussed how to build that. Basically, the whole idea is to use this kind of a sample UV surface, and if I directly plug that to the geometry, there is nothing because we need a source to evaluate. So let's plug the geometry into the source. So immediately we can already see some effects or some deformation of curve, and which is kind of resulting in a kind of a show shape. And now we can we can change some parameters to make it more kind of obvious and increase in subdivision. And let's use a bevel curve so that we can see everything clearly. You can see the radius is too high, so let's decrease that with value precision. With exponent 1, then we are essentially outputting 0.1. Let's take that to 2, so we're outputting 0.01. So this is the idea. So if I plug this into the radius, then so value precision is giving a kind of a small enough number without any difficulty. Okay, so now we have this setup being done, and there are several issues that you need to realize which is relevant to its UV. So here let's take a UV editor, and previously we've already seen this UV because we unwrapped that. And the basic idea is that we have all this kind of instance of curves or splines in a 3D space, and we are mapping all this kind of position into this UV map. And once we find a location corresponding within this UV map, we take its position into the 3D space. And with this idea, you need to realize that our line originally are horizontal on the x-axis, but this island is actually vertical. So that's why you are having a different flow of lines and geometry. Another thing is these two areas, the top parts and the bottom part, are essentially separated. But now, with this kind of organization, they are essentially connected to each other. So you need to understand these two kinds of difference, which is causing some whatever, which you can call that a bug or undesired result. For me, in this particular case, I'm just going to rotate this island. So in UV editing, you can hit L so that you select all islands at once. And by moving that, you can also see how UV map is essentially affecting our mapping result. And here I'm going to hit L and rotate that by hitting R. Rotate it 90 degrees and put that to the bottom. Okay, so once we've done that, let's just scale it down a little bit. You can see we're changing the angle of how this curve flow on this shoe, and we can keep increasing the count to make it looks nicer. And you will realize there are some problem with this kind of seam, but this is just the nature of this method. There is no real way to solve that or filling this gap other than increasing the sampling precision. But I think this is also realistic because when different parts are connected in a cloth stitching, sometimes it will just happen this kind of issue. So you need something to cover these parts. I think, yeah, basically this is how it looks. Anyway, so this looks kind of nice, but we're going to deal with certain issues, or I want to deal with certain issue, because we are originally kind of straight lines, but this is a kind of curved surface in this UV unwrapping. That's why you have this kind of curved flow of lines. It's not straight. So you can edit UV to make it straight. So what we do is we select this a single component. I'm going to hit S and hit Y and hit 0 to straighten up this edge. And I'm going to keep continuing with this Y. And now I'm going to hit S, hit X, and hit 0. Hit S, hit X, and hit 0. So that I have a rectangle compared to other places. And then I'm going to right click. There's a furrow active quartz. Once you hit that, I'm straightening up everything in this UV space. Okay. Basically, this is the idea, and we just repeat the same process So let's hit S, hit X, hit 0. That's no. Let's only select the edge or the points. Hit X, hit S, hit X, hit 0. Hit Y, hit 0. Hit Y, hit 0. And select this face. Right click for active quads. And yes, we having this. So once we've done this thing, you can see the lines are basically straightened, and it also cleared the seam a little bit. I think this is just an accident. It's not really intentional. Yeah, but it looks kind of nicer, in my opinion. And basically, that's the idea. Up to now, what we have done essentially is basically mapping a 2D geometry into 3D space based on UV sampling results, knowing that this technique can work both on either curve or mesh, or it does not really matter what it is, except the volume, of course, and the source mesh must contain UV. Other than that, there are kind of disadvantages, but in this particular case, it works perfectly fine. Okay, and the rest is just to complete this animation, which is very simple. Like it's just a set position, noise 3D, and the directional fold. Okay, these basically 3 components. But the issue is that whether you do this animation before or after. The issue is that the difference between before and after in this case is that the evaluation of this directional fold is based on the position. And one position is on 2D space and the other position is on 3D space. So the evaluation can be different. Other than that, there will be a problem, but we will discuss later. Okay. In this particular case, this evaluation does not matter a lot because both parts, like this part starts at the front, that part starts at the front. So the evaluation probably does not really matter. You can do this animation after. Okay. It will probably be better to do this after because we will encounter another issue if we do the animation before. However, to demonstrate that problem, we're going to do that animation before. So let's take a look with this 2D space. For better visualization, I'm just going to use the bevel curve to give it some kind of volume. And I'm going to decrease the count just for better visualization. Okay, and you can directly plug this noise 3D into the object, then immediately you have kind of noise. This noise looks kind of very continuous. If you want to make it very discontinuous, then you increase the frequency, but then it becomes very kind of ugly with all these kind of knots. Okay, so you want to keep a kind of medium frequency, but how can I make different splines to move differently, like a flow or whatever other stuff? So you take a spline index, spline info. So that you give every spline a different seed. So now it becomes very discontinuous while having a medium frequency. Okay, so this is the idea. And by plugging the directional fold, then you can see how the result looks like. Part of that contains noise, the other part contains no noise. And by changing this directional offset, you are moving that. And by increasing this scale offset, you're smoothing out this transition. Instead of having kind of very sharp transition in between, I'm smoothing out this noise transition. And you can flip the direction, does not really matter. Okay. So this is basically the idea. Here, I also would like to add a kind of transition. So we start from nothing, and then I have turbulent spline. Finally, everything goes to flat. The way to do that is very straightforward. You can use set curve radius. When the curve is too thin, then you do not see them in the viewport unless you increase this radius size. Another method is to really delete the geometry as we discussed, you make a selection to delete some part of a spline. Right now, everything is being deleted with this selection. Okay, so these two ideas are basically the same. The only difference is that in this set curve radius, you can have a transition, just like we've done with this noise 3D. But for deleted geometry, it's really a yes or no. So you delete that or do not delete that. Okay, here we can plug this fourth into delete geometry. As you can see, the turbulent part has been deleted. So in order to preserve that, what we can do is to use greater than. And we can set that when the fourth is greater than 0.9, then we delete that. So we actually delete part of spline, but we also preserve part of turbulence. Okay, and you can manipulate the scale offset to increase the proportion of these turbulent parts, because by increasing this scale offset, the range between 0 to 1 will be larger, and so that there will be more area not included inside this selection. Okay, so this is the idea. And so this is the animation. This is animation on a plane. Everything is unidirection, so we goes to the right from nothing, goes to turbulence, and finally everything goes to be straight. So when it's remapped to a UV space, we expect the same to happen. But if we look at our final output, so let's go back to beginning. Let's take a group input so that I do not traveling inside the node tree. I can directly increase the count in modifier panel. So now if we play this animation in a 3D space, then you can see something is weird. It's unexpected. The reason is that it's growing in two directions. It's on the left, also on the right. Another important thing is we didn't animate splines, but there is a kind of glitches. You can see this kind of spline is going up and down for some reason. It may look kind of good. You may output this animation. It looks kind of interesting, but it's not desired because it's different from what we've seen earlier. So what's wrong with this setup? The reason stems in the principle of this UV deformer. When we are trying to remap this coordinate, we are using a concept called a bounding box, because we need to know the area to remap all this kind of vector. So we have a map range, and when we remap vector, we need to know the minimum and the maximum. And this minimum and the maximum can be obtained from bounding box. So that if we know this entire bounding box is -1 to 1, 1, we can remap that to to 0, 0 to 1, 1. So that which corresponds to a UV space. Okay. However, if we look at this bounding box, this is how it looks like. It's not just a -1 to 1, 1, but it also has a kind of z coordinate. This is because our spline is turbulent. Another more important thing is that by deleting this kind of curves, you can see this bounding box is not stable. It's just going up and down and review itself from the left. And this is what's causing the glitch and many other issues. So in order to solve that, we need a custom bounding box, and that's why there is a socket called custom bounding box in the preset. So that we need to make our bounding box to ensure that all this kind of map range or remapping process is stable instead of being going up and down, whatever. Okay. And to do that is very simple. We just create a kind of cube to cover the whole area. So this cube may be 2, 2. Something like that should be enough. You just need the height to cover the whole area of animation. Then everything should be done properly. So now finally we output the curve. So I didn't really change much of node tree. I really just put a cube into this custom bounding box, and you will see how the animation looks different. So now we play this directional fourth. You can see it starts from the end, and it's kind of unidirectional flow to the front, revealing itself. And we have turbulent spline, and finally everything goes to be flat. So this is the animation. If you want to flip the direction, you just flip the direction. Okay, so now we finished this animation. So this is the trick of this custom bounding box. It really depends on the kind of animation that you are making, but sometimes you may want to worry about this kind of issue when you are using this UV deformer. Okay, and yes, basically that's it. One more thing I want to add is I want to add some noise within this setup, because now the noise is actually staying in its place. But you can add a translate position to the custom vector. So now you can actually add a kind of flow of this kind of curves. This method is basically the same when you are working with the position attribute inside this vector of a noise texture. So this is it. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.